Hello and welcome back to the channel. In this series I'm trying to show you one of a little project I wanted to do. Hasn't been produced yet. I haven't created any PCB or anything. It's not a working prototype, so it's just a starting point of what I'm planning to do, and hopefully get it working. So it's gonna be a little device, portable device, with a 1.69 inch LCD touch display from Waveshare. That is the little display. It cost only $15. So it's a touch screen and pretty small. The display size is that the overall dimension are 33mm by 41mm. So it's a pocket wearable device. So using this device as a display and using the Raspberry Pi, the RP2040 microcontroller from the Raspberry Pi company. You can find the data sheets in their website. So, and then there is a hardware design which is make things much easier. So this is the data sheet if you want to have a look, and this is the hardware design where it does show you the minimal requirement for getting running. So that I'm gonna be using this microcontroller for running the display and also running the gas sensor BME688 from Bosch. This is a little nice sensor device which does temperature, humidity, and detecting lots of sorts of gas. Also is AI integrated. It's got integrated AI, so you can actually make program it to learn different gases. So the use of this sensor is either to air quality monitor, or it can be used for to sense food where it could become rotten. So if you put in the fridge, it will sense the air inside the fridge, and then if you have any food that start to smell or go rotten before you actually smell it, it will should pick it up. So that's the idea of the little project I have in mind. So this is the 3D version of the LCD display. This is provided by Waveshare, so you just import it into the card, and what I planning to do is to build a little case. This is just the first design, so it may change shape to hold a PCB around with the same size, so with connectors. This is all stuff that I have just designed it just to have an idea of the space I need to make the actual body. So this was actually started to design with the STM32, but I decided to go to the RP2040 for the time being, because I have connected the LCD screen to a Raspberry Pi Pico, and then it's running quite fine, whereas on the STM32 I have some issues with it. But it may become may be able to in the future do both platform. So that is the overall ideas of my little sketch. So the little hole at the back is for the sensor, which is, I think, is gonna be better to have it in this on the side. So because you could stick this one inside the fridge and then you will be covering up the sensor. So the position of the sensor is yet to be decided. But this is gonna be a live recording session, so allow for mistakes, cancellation, deleting stuff, redoing it. So there will be lots of sort of things going on. So to start, I will start to make this schematic. Do I have already something open? Oh no, I don't have a project, sorry. So I start to do a schematic, and I am going to go to my project Pocket, Raspberry Pi. This is the files they allow you to use, so you could download directly the KiCad files, but that way it's a bigger board than the way I want to do, so I prefer to do it from scratch. So the device is called a Pocket, and I'll just RP2040. Oh, 2040 is the device. So open there, file name RP2040, and I'm going to save it, and then I'm going to open the schematic. Let me pull the schematic into this, into this page, and then make a start. So let's have a look. First of all, I am going to pull the actual device. So we click on that. And we look for RP2040, which is this one here. And we press OK. And I'm gonna put that one anywhere. Then the schematic provided, well, if you look at the data sheet, you need to pull lots of decoupling capacitors per each of the VDD, etc., etc. So we're going to start to populate the schematic with the components we need, and then we'll connect them all. So we also need, for connection, we need a USB micro. That's that one. So we're gonna put that one there. We need a capacitor. We will need several capacitors. Let me get this C small because I prefer that. And then copy and paste. We need a couple here for the regulator. For the regulator, they suggesting a NCP 1117, 3.3 volts, 3.3 volts, SOT, yeah, that one. So that's what they recommend. So let's start to line that stuff up. Right, let's connect the first one. The value is at 10 micro, and then also this one is at 10 micro. We need some powers. We need the ground first. And we're gonna put the power there, and then we're gonna link that one there and that one there. We don't need to have this one connected, so I disconnect it. That, and then we need to copy and paste this one. I'm gonna put one there, one there, and one there. So let me pull this one up a bit, this one up a bit. And we connect everything to there, there, and here we want a 3.3. No, wrong one. We want a 3 volts. Three volts there, and then we need a V bus. Is it the V bus here? And we put a V bus there. Pull it back up a bit so it's in line with that one. Then here we need some labeling up. So add a label, and this one will be USB D plus. And then it will be a USB D minus. I don't like when it does like that, so let me reconnect nicely there. And that is the regulator section done. Now we need to put a memory, so a flash memory. So we're using the W25 Q128 JVS. That's the one, and we're gonna put that one roughly there. Then we need connect 0, 1, 2 pin or socket. Is it only this one? will put pin for now, and then I'll see if I have to change it later. So what we got that one there. Don't need to put that one, take it space. So now we need some resistor, so we press R, and again I'm gonna use R small, take less space, we rotate it, we put that one there, and then we put another one there. This is a 1K, and this is actually do not fit, so you can avoid this one if you using this flash memory. If you use something else, you may need to use that one. So we just connect that to that, and that go to ground. Control copy, Control V. That. Let's have a look. I need to move this one a bit over there because I need to write labels. We got the first one is QSPI SS. Then we go QSPI clock. Okay, I will need to readjust. Then we have another one, QSPI SDO, QSPI SD1, QSPI SD2, and QSPI SD3. That, and now we can go and connect all those. And here, let me have a look. I'm gonna move everything that way. I'm gonna move that one there, so I can actually move this one slightly over, so it's a little bit tidy. Then we have a ground going there. And then we have let's go up there. What we got here? We got these 3.3 volts. Copy, Control V. You can put that one there. That one is connected there. And then we have a capacitor to ground. And then flash memory is done. Let me move this one out a bit. So we need several. Okay, what we can do now, because we've done this one, I could actually copy and paste QSS. Copy and paste the clock. SDI 0. And SD3. Right, also should be all good, so I can go and connect them. So I've got SDA 0, SDA 1, SDA 2, SD3, and the clock. Then we have, let's connect the D minus. So we need, oh, I don't want that one actually. I got the wrong. I had the wrong size. So now I need to no. Okay, that one, and let's have a look. Still. Okay. And we have a 27 ohm and 27 ohm. Right. And we're using the plus to go with the plus. Let me put it there, and then we connecting the minus to the minus. The minus to the minus, and the B to the B. Okay. I think for now we can stop the video here. I don't want to make it too long and too boring for you guys, so I will see you in the next one. If you have any comment, as usual, please leave them in the box below and I'll try to reply to you as soon as possible. Thank you for watching. Bye bye.